Hi and greeting. Our group would like to present project about exploring web browser with data structure, that is Microsoft Edge. First, I would like to introduce our group member consists of me, Muhammad Khairul bin Mohammed, and Fatnin Hanan Abdul Muttalib, and the last one, Nur Sabrina binti Mukri. Welcome to our video presentation. For the content of this slide, what we will talk about is number one, we will be about application title and description. Number two, how the application works, list of operation, now demonstrate the use of the data structures operation. Number three, one operation and algorithm, running time and estimate the efficiency of the algorithm. Conclusion of the finding, running time, and the of the algorithm. Number four, existing application code with output. Number five will be conclusion and summary. Okay, next, web browser, brief introduction. A web browser typically use various data structure to efficiently store and manage different types of data. Data structure help browser handle and optimize various operations, including rendering web page, managing user interactions, handling network requests, and maintaining history and state. Microsoft Edge is a web browser developed by Microsoft. It is based on the Chromium web browser and it is available on Windows, macOS, Android, and iOS. Edge is designed to be a fast, secure, and privacy-focused browser. It includes features such as tracking prevention and ads blocking and linking. Edge is the default web browser on Windows 11.
Yeah, Assalamualaikum. My name is Fatih Hanan. So I will talk about Microsoft Edge operation. So the first operation is navigating the web. You can use the address bar to enter a website, or you can search the link through the website. You can click the link, and you also can use arrow keys on your keyboard to navigate through the page of the website. So the next is searching the web. You can use the search bar to search for information on the web. You can type in the keyword or phrase, and Microsoft Edge will return a list of websites that match for your search. And the third one is opening and closing tabs. So as you can see in Microsoft Edge, there is a plus button on the address bar, and you can click the plus button to opening a new tab, and the X button to closing the tab. And also lastly, the bookmarking website. You can bookmark the website that you wanted to visit again later. To bookmark a website, click on the star location on the address bar. Then you can view again the bookmark website that you have choose. The fifth point is reading article in reading view. So reading view is a feature that allow user to read articles without a distraction. To enable reading view, click on the AA button in the toolbar and select reading view. So next is inking. Microsoft Edge support inking, which allow user to write or draw on the web page. To enable inking, click on the pen icon in the toolbar, and you can use your mouse or stylus to write or draw on the page. So next is extension. Microsoft Edge support extension, which are add-ons that can add a new features to the browser. Okay, to install the extension, go to the Chrome Web Store and search for the extension that you want. Next is view history. You can view a list of all the history website that you have visited, and you can click again on the website in the view history. So next is demonstrate the use of the data structure operation in Microsoft Edge. So there is two operations, that is stack and doubly linked list. A stack is a data structure that use LIFO order to store data, and this means the last item added to the stack is the first item to be removed. So Microsoft Edge use stack to store information about the history of visited website. So next is doubly linked list. In Microsoft Edge, a doubly linked list is a data structure that connects elements with reference to the previous and next element. So it enables efficient traversal in both directions, and is used to internally for various tasks within the browser rendering. For stack operation, there is two methods, that is push and pop. Microsoft Edge for the push operation adds a new tab or URL to the top representing the action of the opening a new tab or navigating to a new web page. It maintains a sequential order of browsing activities. For the pop method in Microsoft Edge, the operation in the stack removed from the top bar, a top tab or URL representing the action of closing a tab or navigating back in the browser history. It helps manage the most recent browsing activities. So this is the example of stack for the push operation. This stack array shows the push operation, which is Facebook is being inserted into the stack from the top. After Facebook is inserted, the index 0 becomes Facebook while the index 1 is WhatsApp. So this is the example of stack for the pop operation. This pop operation shows the index 0, which is Facebook, is out from the stack from the top. After Facebook is pop out from the stack, the index 0 of the stack is WhatsApp. So for more detail about doubly linked list, a doubly linked list is a data structure where each node contains a value and two pointers, one pointing to the previous node and another pointing to the next node. This dual linkage allows for the efficient traversal in both directions, making it useful for scenario where bidirectional access is required. In the context of a web browser, a doubly linked list can be utilized to manage browser history, tab lists, or other dynamic components. So as you can see, this is the example of doubly linked list. Each node contains a value and pointers to the previous and next node. Then for the image, we can see that the head is connecting to the Facebook, and for the next node is connecting to the WhatsApp, and the next node is connecting to the now. And for the previous one, WhatsApp is connecting to the Facebook, and previous node is connecting to the now.
Okay, next is to find running time and estimate the efficiency of the algorithm. The operation that we choose for Microsoft Edge is view history. The running time of the algorithm is linear, where n is the number of the website in the history list. This is because the algorithm has to iterate through each website in the history list in order to find the website that the user is looking for. The efficiency of the algorithm is good as it is able to find the website that the user is looking for in a relative short amount of time. The running time of the algorithm is linear, which is a linear time complexity. This means that the running time of the algorithm is pro- proportional to the number of websites in the history list. The efficiency of the algorithm is also good because it does not require a lot of memory or CPU
Okay,
power. Next, running time and estimate the efficiency of the algorithm. Here is the code for the algorithm and running time. Here are the steps that drive to the final answer for the algorithm. Number one, the algorithm starts by getting the history list from the browser. Number two, the algorithm then iterates through the history list, visiting each website once. Number three, for each website, the algorithm displays the website URL. And number four, the algorithm terminates when it has reached the end of the history list. Okay, next, we will conclude of the finding, running time, and efficiency of the algorithm. The algorithm for viewing history in Microsoft Edge is a simple linear search. It has a running time of linear, where n is the number of websites in the history list. The algorithm is efficient and can find the website that the user is looking for in a relatively short amount of time. The algorithm can be improved by using a more efficient data structure to store the history list. Here are some of the key findings of this study. Number one, the algorithm for viewing history in Microsoft Edge is a simple linear search. Number two, the running time of the algorithm is linear, where n is the number of websites in the history list. Number three, the efficiency of the algorithm is good as it is able to find the website that the user is looking for in a relatively short amount of time. Number four, the algorithm can be improved by using a more efficient data structure to store the history list.
Hello, my name is Nur Sabrina, and today I will identify the collection class and user interfaces of Q data structure that Microsoft Edge use. So, Microsoft Edge use Q data structure to manage incoming network requests. So, how does it work? Okay, when the browser sends requests to retrieve web pages or resources, this request could be enqueued and processed in a first in first out order. Let me explain about how queue work on this. Okay, as you can see, the code here, the queue follow the first in first out FIFO principles, where the request that enter the queue first will be processed first. Okay. Why we choose queue? It is because when using a queue, it is ensure that the requests are processed in the order they were received. It is maintaining fairness and preventing certain requests from being consistently prioritized over others. Okay. It also ensures that the browser handles each request systematically. Okay, let's move to the next slide. Okay, now let's identify the collection class. Based on this code, as you can see here, the collection class is linked list. Okay, in the code, we create a network request queue class. It uses a linked list to implement the queue. Okay, the linked list class here is used as the underlying data structure to implement the queue. It provides the necessary operation like adding, removing, and accessing element. Okay, now let's identify the interface. Here there are two interfaces. First, queue interface, and the other one is list interface. As you can see there, I made queue interface as a green and the list interface as a blue. So it is easy for you to recognize it. Okay, first let's talk about the queue interface. The queue interface here using the linked list as underlying data structure. It defines the common methods for a queue such as NQ, DQ, is empty, and size. Okay, now let's talk about list interface. The list interface here provide functionality such as adding elements to the end of the list at last, and removing elements from the beginning of the list, pull first. Okay, now let's take a look about the operation for link class. There has four operation here. First at last, second pull first, third is empty, and lastly size. Okay, for the at last, it adds the specific element to the end of the list. Next, for the pull first, it retrieve and remove the first element from the list. Next, as you can see here, is empty. Uh, it check if the list is empty. And lastly, for the size, it returns the number of elements in the list. Okay. Now let's take a look about the operation for queue interface. They have four operations here. First, enqueue. where they add a network request to the end of the queue, which is at last. Next, the queue. Okay, the queue here, it retrieve and remove the network request at the front of the queue, which is pull first. Next is empty, where it check if the queue is empty. And lastly, size operation, where it returns the number of elements in the queue. Okay, now let's move to the operation for list interface. They have also four operations. Okay, for the list interface operation here, it implemented by linked list. Okay, first they have at last operation. Next they have pull first operation. Third they have is empty operation, and lastly they have size operation. So basically the functional is the same with the linked list operation. So I include the full code here, and this is the Java main class. Okay, here is the Java class. Okay, this is the code for network request class. So here is the output. As you can see there, processing request. First, the enqueue and dequeue. Next, we follow with the net process. So it's use first in and first out process. In conclusion, Microsoft Edge uses different data structures to manage its functionalities. Stacks are used to store browsing history, double linked lists for managing browser history and tabs, and a queue for handling incoming network requests. The stack store visit website information, make it easy to access browsing history. The Doubly linked list help navigate through browser history and manage open tabs. And the queue ensure that incoming network requests are processed in the order they arrive, following the first in, first out principle.